Hello everyone, welcome to Driven Maths and Physics. Thank you so much for tuning in today. Today we'll be looking at polynomials, and we'll be introducing the topic, and then we'll build from there. So the concept we're looking at today is the concept of long division and how to do this with regards to polynomials. Okay, first things first. You have to remember the way we're doing long division in primary school, and even maybe parts of JCE as well. And so it's the same understanding that we use when we're calculating using long division with numbers, and also we apply the same to polynomials. We just have to make sure that we are obeying the rules of algebra as we do it. Okay, so if you remember very well, let's take, would say something like 21 goes into something like 215. What you would normally say is 21 into 21. You would say 1 times 21, and then you would drop it down there, subtract the 2, get a 0. Okay, the remainder would be you would drop the 5 going downwards, and then you say 21 into 5, you will say 0. Okay, 0 times that, it will be 0, and the remainder will end up being 5. Okay, so you can see that 21 actually goes 10 times into 215, and there's a remainder of 5. This is how you are doing long division. And after you do the calculation, what you also notice is that if you had to multiply your answer, which is normally called the quotient, you multiply it with the divisor, okay, 21, and then you add the remainder to that, the result from the multiplication, you should end up getting the dividend, okay, the number that you began with. Okay, so if you do that, if you multiply this times that, and then add the remainder, you end up getting this. Okay, so if we do that, it will be 210 plus 5, you end up getting 215, which is the same thing as that. Okay, that's what you see from long division using numbers. Okay, so it's the same understanding that we end up applying when we are dealing with long division and polynomials. Okay, now we need to know a few things before we do actual examples. Okay, now take note of this. You multiply the quotient multiplied by divisor. After you multiply, you add the what? The remainder. Okay, this should give you the dividend. Okay, remember this. This is very, very important. Now, there are a few rules that we have to look at when we're doing long division and polynomials. The first rule is that you have to make sure that the polynomials that you are given, both dividend and divisor, must be written in descending powers of the variables. Okay, they must be written in descending powers of the variable. Okay, now before I look at that, let's make sure that we're on the same page to begin with. Okay, what are polynomials? Okay, some of you may be hearing me just mention polynomials without really knowing exactly what they are. Okay, now when you are starting to do algebra, okay, and maybe in primary school, later years of primary school, and also Form 1, what you came across were terms like x squared, 2x, 3xy, 2ha, things like that, okay, in algebra. These ones were just single terms. Sometimes they had two variables in them, sometimes one variable. And these ones were called monomials. Maybe that's not the name you were using in JCE, but that's what they're called. It's mono. Okay, you remember when someone is having a monologue, what it means is they're talking to themselves. It's just one person involved. So mono means one. Okay, and because it means one, every algebraic term, okay, that is just one term on its own, and it may have many variables in it, but if it's just one term, it's called a monomial. And then there's also something called a binomial. A binomial, this one may be x plus y, x squared plus y squared, 2xz plus y. All these are binomials. Why? Because they contain two terms. They may have more than one variable each term, it doesn't matter, but as long as they contain two terms, they are binomials. Bi means two. Okay, and then we have polynomials. These ones are algebraic expressions with more than two terms. So they may have 3 terms, 4, and even just going forward as many as you can think of. So this one, we can have x squared plus 2x plus x to the power 3 plus 2x y. This one is a polynomial. Why? It has more than 2 terms. So everything, poly means many. You remember when you're doing polygons, we said polygons are many-sided figures. So that's poly means many. Okay, so when we're talking about polynomials, we're still dealing with algebraic expressions. Even when you're doing quadratic expressions, you will deal with polynomials without really knowing it. Okay, as long as they have more than 2 terms, they're called polynomials. Okay, very important. When we mention that, just know this is what it exactly means. Now, let's look at the rules for long division of polynomials. That brief introduction. Now, both dividend and divisor must be written in descending powers of the variable. What does that mean? Let's take we're given a polynomial that says 2x to the power 2, x to the power 3 plus 4. Okay, this is a polynomial, but if you're going to do long division, make sure you put them in order. Okay, in order. These powers on each term, they are called degrees. Okay, so make sure the exponents are in descending order. Okay, so what is the highest exponent, or what is the highest degree, or which term has the highest degree? So you will notice that x to the power 3, the 3 is our highest degree, and then we start with that. Then we come descend to the next one, which is 2x to the power 2, and then descend to the next one, which is x, and then descend to the constant. Okay, so they always have to be written in descending powers before you start doing long division. Very important. Okay, very important. So start with the term with the highest degree. Degree simply means highest power or highest exponent. Okay, so sometimes we use the term degree. Like here, this polynomial right here, if they asked us to say what is the degree of this polynomial, you say it's the degree of 3 or the 3rd degree. Why? Because the highest power is 3. But what is the degree of this term? Is 2, because that is the power of the variable. Okay, so we're only considering the powers of the variable. Write them in descending order. Okay, now next thing we have to look at here is a rule. The next thing is, if a term is missing, a 0 term must be inserted in its place. Okay, let me give an example. Let's take we have x squared plus 3x plus let me write it properly. Another example will do, I think. Let me start with this one. X to the power 4 plus 2x plus 4. Okay, normally these equations are supposed to take the form, if it's starting with x to the power 4, the next one must be x to the power 3, the next one must be x to the power 2, then it has to be x, then we end with a constant, okay, which may be c. All right, so we have to have every term descending like that in order. But sometimes we have polynomials like this, where some of the terms with certain degrees of the variables missing. Okay, like here, what is missing is x to the power 3, x to the power 2 is missing, these two. So it says that if these things are missing, before you do long division, make sure you insert them. But now make sure the coefficient is 0. So they're saying make sure you insert a 0 term. Okay, how are we going to write that? It will be x to the power 4 plus 0 x to the power 3 plus 0 x to the power 2 plus 2x plus 4. Okay, we have changed nothing here because these terms of introduced are simply 0 terms. Why is it important? It's because it will help us in doing long division as we are doing the divisions and making sure we're descending downwards there. These things will come in handy. We'll know where to place our answers on the quotient. You will see it as we're doing it, but they're important. Make sure if they are missing terms with certain degrees, make sure you include them as 0 terms. Don't just solve it the way it is here. No, make sure you include them. Okay, now let's do an example, because this is nice to talk about and we gotta do an example. We have to do an example. Okay, so let's start with something simple. Let me put myself here. Okay, let's start with something very, very simple. Okay, example. All right, number 1. So the first example is saying that given that f function of x is equal to x squared plus 7x plus 12, okay, they're saying and another function of x come on, okay, another function of x is equal to x plus 4, okay, x plus 4. They're saying divide fx by g of x, okay. So divide f of x and by g of x. So what they're saying is divide this by that. Okay, so what we're going to do, the same way we're doing in long division with numbers, what we're going to do is we're going to write our division symbol, division thingy, I don't know what you call it. We'll write it there, another line like that, okay. Then here we'll indicate x plus 4, okay, and then underneath here we'll put the dividend as x squared plus 7x plus 12, like that, okay. Now I want you to really pay attention in how we're going to do this. So the thing that divides into our dividend is the term with the variable, okay, the first term with the variable, the term with the highest degree in the divisor, okay. In this case the variable is x, so we're going to divide x throughout on each and every term, okay. Now pay attention. So if we say x divide into x squared, so that simply means we're doing x squared divided by x, which will give us x. And you see that the answer that we get when you divide that into that is something to the power 1, okay. So where we're going to write that answer is on the term in the dividend that has the power 1, okay. So if we divide x into x squared, it's x, so we write it right here because here there's a term that has the power 1. That's where we line it up. And you see now why we need to have 0 terms in the polynomial. It's because of this, okay. Now when we do that, we say x times x, you get x squared. Then you multiply x times 4 again, that will be plus 4x. And then like we do with numbers, we subtract, okay, we subtract. And what we get from there is x squared minus x squared is 0. 7x minus 4x is 3x, okay. Then we drop down the 12. This is so easy, isn't it? So you take the x again into 3x, okay. So that means you're doing 3x divided by x. What you get is a 3, and what you're getting is a constant. So make sure you write that answer where the constant is in the dividend. You put it there, 3. And then x times x, 3 times x is 3x, and 3 times 4 is plus 12. Then you subtract, okay. And what you end up getting is a 0. What you end up getting is a 0, okay. You put a 0 there. That's a remainder, okay. The same way we're doing with numbers now. This tells us that if we multiplied the quotient multiplied by the divisor, it should give us this after adding the remainder, which is 0 in this case. So what we'll write is x squared plus 7x plus 12 is equal to x plus 3 multiplied by x plus 4 plus the remainder, which is 0, okay. So we just write x squared 7x plus 12 equals x plus 3 x plus 4. This should be our response. Can you see that? That's how you do long division with polynomials. It's real easy, isn't it? Okay, so let's look at the next thing. Okay, let's continue from there. Long division. Let's continue from there. We'll do another example. I think the examples will get a bit more complicated as we go, so make sure you are following. Number 2. Okay, the next one we're doing is it says that divide